So cloud native. So what does cloud native mean, right? So let's imagine a scenario where, company X, they're running on premises. They did what's called a lift and shift. So lift and shift is they took their servers running on premises and they picked them up and moved them to AWS, right? And I'll use AWS as the example. It could be any other cloud provider. They moved it over, and then once they had the servers running on AWS, they weren't running efficiently, right? Because when you lift and shift something and you don't make the minor tweaks that you need, you end up creating something that's not optimized for your specific use case on the cloud, right? And that's the big asterisk there is you want it to work on the cloud. And so what ended up happening is that this company X, once they moved it, they started saying like, hey, we were running more efficiently on premises. And people started saying, why did we make this move? We're now spending more money and we're running less efficiently and we don't know what we're doing, right? So those three things. And the big thing is that when you move something to the cloud, you have to start changing the way that you think, right? You're no longer thinking from an on-premises perspective. You need to start thinking about a cloud native perspective. And cloud native is building inside of the cloud, using those services and leveraging all the fully managed aspects, right? Leveraging the automation and leveraging the idea that if you use these services and plug these into your application, you don't have to hand roll all these things, right? So if you have a server that's running a queue and there's a queue that's fully managed by AWS, kill that server, like just kill it, like, because you don't need to keep maintaining this thing. Find a way to take the same functionality that you already have, and then move it over. And one benefit or one strategy that I would say that you can look at is that the same way that when you look at the compute model for AWS, there's multiple layers, and each one of those layers can be swapped out. That's how you should write your backend code, right? Sure. And this is how you should write your front end code as well. When you're writing code, it should be written in layers that one piece can be swapped out. And so when we talk about multi-cloud strategy and how do you achieve multi-cloud in serverless or with containers or anything else, you want to have these layers where if you're using a service, if you're using AWS SQS, which is a queue system for AWS specifically, right? If you're using that, but then you have to switch over to, I may use the wrong service for Google Cloud, please forgive me, Dataproc for Google Cloud. If you want to swap out SQS for Dataproc, you're going to have some line of code inside of your backend that needs to be replaced. And so if you create your code in a way where all those dependencies are able to be easily be swapped out, you're multi-cloud at that point, in my view, right? So you're not locked in at that point. If instead though, you go the opposite direction and you have one function that hits SQS and hits S3 and does all these things, you're going to have a very hard time swapping services. So change your perspective, come in with a fresh set of eyes, start thinking about how can we leverage as many fully managed services as possible, and how do we break apart our application to be modular and to follow this kind of microservice distributed architecture, right? So when you do microservices, each piece is isolated, right? And when you have that isolation, you're much better able to, you can create an entire team just around Lambda functions and around like your S3 front end, like static hosting, right? And so you can have people that are just working on one tiny piece of the application. And what happens, what's really cool about it is that, let's say you broke apart your cloud functions by the actual API path, right? So let's say you have /users and /products, right? Well, /users and /products, those could be two separate Lambda functions. And those functions could actually be completely isolated from each other, meaning that one team could work on the users and one team could work on the products. Whereas before, you might have both of them together on one container running or on one server running. And so if one break happens, it breaks all of it. But because you're packaging these things separately, somebody could break the /users endpoint, but then the /products endpoint will stay working. And so you can break it down for a one API path where it's a post request to create a new user. That could be a separate function. And then at that point, it's so modular and so broken apart that the chance of you having downtime with some supporting automation is extremely low. So,
and this is how you get that 80% savings number, is by going through this process. So it's like, I think maybe people can begin to get overwhelmed or think like, well, this is difficult, maybe I shouldn't be doing. But if you want to save that $800,000, like, is it worth that? If you want to,
Yeah,
like, it leads, it all pays off in the end. But there does require some upfront work in order to think differently. You know, and I think, you know, it's just like when you're starting anything, like when you're a beginner at anything, like you have, there's a learning curve of like, okay, do I understand this new thing? You know, it's hard to learn a new language, but it's in a way what you're literally doing.
Yeah, and you know, and then just to go back to the cost thing there, you know, for a company like, let's say, you know, Puma, right? Let's say Puma is running on AWS. I have no idea, by the way. So if that is true, no insider information. So Puma spending $5 million on servers, and then they cut it in half, or they cut it 70% or 80% using serverless, and they go from spending, you know, let's say $5 million or $10 million down to $2 million, right?
Yeah.
How many shoes do you have to sell? How many shirts do you have to sell to make an extra $8 million per year in revenue, right?
Yeah.
And so what type of expansion do you have to do, and how many years to be able to see that benefit take place, right? And so you're paying for this already. You're already paying for it. Like, why are you overpaying? That part blows my mind sometimes. Companies, from what we've seen doing contracts around Portland, around you know, the West Coast, companies, these gigantic companies, they are spending all this money, millions of dollars in servers and other aspects, and they have no cost team. Like, where is the cost saving team where you're paying one person $80,000, $100,000 a year, or a team of 3 people, but they're then going to save you $200,000, $1 million a year, and then you spread that cost savings over 5 years, and if you cut, let's say the cost that we just said with Puma, $8 million in savings in a year, right? $8 million in savings spread over 5 or 10 years. You know, now what is $80 million?
Yeah.
Right? Like, what is 50 to $80 million mean in business value, right? Yeah. Because you're already spending the money, and you don't have to sell any new product. You don't have to design something new. You don't have to recreate something. Yeah.
Yep.
So, yes.
One thing we're very passionate about
here, very passionate.
Serverless Guru.
Yes.